cell, second time in this cell, and so on. So these are output of 200 regressions, and the sum is 4. This means in all these cells there are 4 regressions which are significant. What we were expecting, we have simulated the data 200 times, and in 200 times we are expecting to see 10 significant regressions, but this time this is less. Remember that in statistics there is nothing guaranteed. The general pattern you can predict, but specific number you cannot predict. We are expecting 10 regression to be significant, so it could be 10, it could be 9, it could be 4 and something close to this number, but it will not be 200. It will not be 150. So once again, I'm regenerating all this data. Basically now we have a table. If I'm asking it for regeneration, it will regenerate the whole table. It will do another experiment in which it will draw the data 200 times, and every time it will calculate the t statistics and then will write in this column. So let me press delete here. So the computer has regenerated entire data, and now I can count how many columns are significant. Basically selection is off now, so I have to reselect so that I can count how many regressions are significant.
So just take the sum of this column, it will be more convenient.
Yes, that's also possible. Now, in this case, there are how many significant regressions? 6. All right. Most of the times, what we have in the data, we have X and we have Y, which are independent of each other, and there should be no significant component among them, and we are running the regression. The regression is telling me same thing. It is giving me significant coefficients only a small number of times. Okay. Now, let me do the same experiment one more times. I am writing here xt. So क्या हो रहा है भाई? यहाँ से लूज है। So, in the next column, I am generating xt, and let me write the formula for xt. This is equal to xt minus 1 plus et. Okay. In the next column, I will generate yt. Yt is equal to yt minus 1 plus ut. I can copy the first observation in the same way. From the second observation, I will differentiate. Now, the xt is equal to xt minus 1 plus epsilon t, and then yt is equal to yt minus 1 plus ut. These are now independent series. Again, these are independent, but these are unit root. See what we are doing. Okay, we have this kind of procedure. Epsilon t and ut, these are independent. Then we have xt, which is equal to xt minus 1 plus u plus epsilon t, and then we have yt, which is yt minus 1 plus ut. So this x is depending on epsilon, y is depending on u, and there is no interrelationship of epsilon and u. So these are independent. This is just like these people are depending on each other, these people are depending on each other, they are independent of each other. Across the two panels there is independence. But now let me run the regression for this data set. इसको यहाँ पे let me calculate again by linest command. This is equal to linest. I am taking this y as dependent variable and x as independent variable, and then true and again true, and then bracket close, and then shift control and enter. Now again you can calculate t statistics here. Equal to the coefficient divided by standard error. And I can ask for calculation, I can ask if this is significant or not, equal to if absolute value of this thing is greater than 2, it should write 1, otherwise it should write 0. And now I am simulating the same data again in the same way that we have done last time. We will make a large table and we'll ask the computer to repeat. How to make table? Go to what if analysis, data table, column input cell, and this is to be put here. What is the sum? 158. We have generated the data in front of me, and I know that x and y are independent. We know that x and y are independent, but the statistics is telling me that out of 200 regressions, about 160 regressions are significant. This is roughly 80%. 80% of the time I am getting wrong message. This is called spurious regression. We have generated data in front of me. This is unit root data, and because of unit root, we are seeing very high probability of spurious regression. This is the reason that we are doing all this analysis. So we have to test for unit root, we have to test for stationarity, then cointegration, then so and so. But there is a problem. What? which nobody realize. What is that problem? Basically, unit root is not the cause of spurious regression. The cause of spurious regression is auto-regression. How? Let me tell you. Here, let me put equal to 0.8 multiplied by this thing. What will happen? It became stationary. If I put 0.8 here, it will become stationary. Is it so? In a similar way, I will transform this series to stationary. Oh, now all the column is regenerated. Let me count how many regressions are significant here. Ji.
Please check the formula of C2 again.
C2? 8.8 multiplied by C2 plus A3. It should be 8.